In section 3.4, we learned the chain rule, which is what allows us to take the derivative of a composite function. So you remember that a composite function has this form f of g of x. And basically the way that we take the derivative of that composite function is that we take the derivative of the outer function here. The outer function is f, so we take f prime, but we evaluate that at the inner function g, and then we multiply that by g prime. So that's listed out down below here at the bottom of the page. So we take the derivative of the outer function, evaluate it, evaluate it at the inner function, and then we multiply that by the derivative of the inner function. Now, in the middle here, they show the Leibniz notation, so that if we think of the function f as being a function of u, and u as being g of x, then we would take f prime of u, so f of g of x, if we want the derivative of that, we would take f prime of u times u prime, or f prime of g of x times g prime. So it amounts to the same thing, but they have this other notation here. dy dx is equal to dy du times du dx. All right, so let's look at a couple examples to see how this works. So these are exercises from section 3.4 in your textbook. So in number 8, we have the quantity 4x minus x squared raised to the 100 power. So let's identify the outer function f of u is u to the 100, and the inner function g of x, that is u, is 4x minus x squared. So this cap f of x we can also write as little f of g of x. So we're replacing u with its equivalent, g of x, that is 4x minus x squared. So what it says up above, which again was copied and pasted out of your textbook, is that to take cap f prime, we have to take little f prime at g times g prime. So let's just go off to the side here. If f of u is u to the 100, then f prime of u is 100u to the 99 using the power rule. So now we want to substitute in for u its equivalent g of x. So f prime of g of x will be 100 times 4x minus x squared all to the 99th power, and then we times that by the derivative of g. So if g of x is 4x minus x squared, then g prime of x is 4 minus 2x. So that's going to be the derivative. Now the common mistake that students make is to put the g prime derivative of the inner function in place of g in the f prime. And I don't even want to write it down because I don't want you to do it wrong, but that's something to be on the lookout for. All right, let's take a look at number 9, and maybe we should rewrite this 1 minus 2x all to the 1/2 power. So in this case, the little f of u is u to the 1/2, or the square root of u, while u, which is little g of x, is 1 minus 2x. So this cap f of x we can write as f of g of x, that is u to the 1/2, but substituting in for u its equivalent 1 minus 2x. And so the chain rule says in order to take the derivative of that cap f, we're going to take little f prime of g and then multiply that by g prime. So f of u being u to the 1/2 means that f prime of u is 1/2 u to the negative 1/2 using the power rule. So to find cap f prime, we're going to find 1/2, but instead of u, we're going to substitute its equivalent, g of x, 1 minus 2 of x, to the negative 1/2, and then multiply that by g prime. So if g of x is 1 minus 2x, then g prime of x is negative 2. So we're going to multiply here by negative 2. Now, FYI, you could do a little simplifying here. For example, we have a 1/2 multiplied by a negative 2, which would leave us a negative 1 in a numerator. And then we can rewrite 1 minus 2x to the negative 1/2 power as 1 over 1 minus 2x to the positive 1/2 power. So for my purposes, simplifying is not strictly necessary. If it's an easy simplification like this one, you may want to do it. If you're checking your answers in the textbook, they may have simplified, so in order to know whether your answer is correct, you might have to simplify yours to get it to look like theirs. But when you're taking a quiz or a test on this, I'll actually ask that you not simplify, because it's going to make it a little bit easier for me to grade, and I want to know that you know how to use these rules. Okay, now those first two examples we can look at more generally. Remember that the power rule that we learned early in section 3.1 told us that to take the derivative with respect to x of x to the power n, we bring the power down and raise x to one lower power. Now we're doing something similar, except that what's being raised to the power n is not just the variable x, but it's a function g of x. But this particular case, where we have a function raised to a power, when we use the chain rule to take the derivative, we bring the power down in front. That's the n here. And then we take that same, what I call the base function raised to one lower power, n minus 1, and then multiply by the derivative of the base function, g prime. And I don't know if looking at this later, seeing all these little lines is going to confuse you, so I'm going to actually take them out. Okay, but let's see how this would work, for example, with number 10. So what I'm looking at is this function 1 plus x to the fourth raised to a power of 2/3. So thinking of it in this new way, to find the derivative f prime, I would bring my power 2/3 down. I would raise that same base function, 1 plus x to the fourth, to one lower power, so 2/3 minus 1 is negative 1/3. And then the chain rule says I also have to multiply that by the derivative of 1 plus x to the fourth, which is 4x cubed. So remember, the derivative of the added constant 1 is 0, and the derivative of x to the fourth is 4x cubed. So this is a way that you can take this kind of derivative where you have a function raised to a constant power without actually figuring out what the composition is.